Welcome to Trigonometric Identities. So today we're going to look at all the trig ratios that can be formed. So the first one that you need to be aware of is that tan theta is equal to sine theta over cos theta. And therefore, since cot is the reciprocal of tan, then cot theta equals cos theta over sine theta. Looking at the Pythagorean identities, so we use the unit circle. Obviously, the triangle drawn has a radius of 1. We've got an angle theta in the corner, and the length of the triangle is x units, and the height of the triangle is y. So using our SOHCAHTOA, sine theta equals to y, and cos theta equals to x. And using Pythagoras, you get x squared plus y squared equals 1. Substituting in sine theta equals y and cos theta equals x into the Pythagoras rule that we got there of x squared plus y squared equals 1, we get our first Pythagorean identity of cos squared theta plus sine squared theta equals 1. This appears on your formula sheet. Now we can rearrange this formula. We can subtract sine squared to the other side and you get cos squared equals 1 minus sine squared, or we could have subtracted cos squared to get sine squared equals 1 minus cos squared. Just rules to be aware of, that we're just using our equation skills. Now to come up with the other trig identities. So when I divide by cos squared, for each of those terms, we get our second Pythagorean identity, which is 1 plus tan squared equals sec squared. And when we divide everything by sine squared, we get cot squared theta plus 1 equals cosec squared theta. So that gives us our 3 Pythagorean identities. Only the first one appears on your formula sheet, sine squared theta plus cos squared theta equals 1. And the other two, you can remember using those rules that we just learnt, or you try to learn them off by heart. Complementary angles. So if one angle in a triangle is theta, in a right angle triangle is theta, that means the other angle is 90 minus theta. And if we were to use SOHCAHTOA and set them all up, you would end up with sine theta is the same as cos of 90 minus theta, and the vice versa of that. Tan theta is equal to cot 90 minus theta, and the vice versa of that. And sec theta equals cosec 90 minus theta, and its inverse as well. So how do we prove trig identities? Well, sometimes they'll actually just ask you to simplify, and so you'll just use all the identities that you know and make the make it as small as you possibly can by replacing with the terms that we actually just found out. Another way is that you start with the left-hand side and prove that it equals to the right-hand side. Or, if it seems that the left-hand side's a bit too difficult, you can always start with the right-hand side and work backwards to get the left-hand side. All right, so let's have a look at a couple of examples. So with the first example, we're going to take the left-hand side, which is tan theta plus cot theta. We're going to change them both into one of the first ones that we looked at. So tan is sine over cos and cot is cos over sine. We're then going to get a common denominator. So with that common denominator, you end up with, on your numerator, sine squared plus cos squared, and your denominator is cos theta sine theta. Now, one of our first trig identities is that sine squared plus cos squared equals 1. So now I split those two as a multiple, and I get 1 over cos theta times 1 over sine theta, and that is sec theta times cosec theta, which is the right-hand side, which is what I was asked to prove. All right, so once again, let's start with the left-hand side. So the left-hand side, 1 minus sine squared theta times cos squared theta all over sine squared theta. We can split those into two fractions. So 1 over sine squared minus sine squared cos squared over sine squared. And on the second one, you'll notice that the sine squared simplify. So we end up with cosec squared theta minus cos squared theta. All right, so let's change those into the rules that we've learned. So cosec squared, well, one of the rules we learned was 1 plus cot squared equals cosec squared, so we'll replace that. And cos squared theta, well, one of the rules we learnt was that it is 1 minus sine squared. So we're going to multiply by that negative out the front, and we get 1 plus cot squared minus 1 plus sine squared. The 1's cancel, so we get cot squared theta plus sine squared, which is what we were asked to prove for the right-hand side. Thank you.